Hey, what's up, ma students? This is Mr. Wilhelm. Good luck evaluating trig limits analytically today.
Thanks. Mr. Wilhelm, everybody. Believe it or not, he was my mentor as I was a first-year teacher. He taught me everything I know. All right, so we are evaluating trig limits analytically. Note that your unit circle is going to be super duper important today and forever and ever. All right, so let's practice evaluating these trig limits. Don't forget, anytime we're evaluating something analytically, what's always our first look? Great, good answer. Direct substitution. So let's have you guys try these three. Put me on pause, and then we'll check your answers. Go ahead. Okay, so hopefully you use direct substitution in all three of these, right? The first one would equal 0. The second one is negative pi, and the third one is 0 again. If you don't know where these values come from, boy, you got some reviewing of the unit circle to do. Excellent. Let's continue. All right, so we do have some special trig limits. This is one of them, okay? So the limit as x approaches 0 of sine of x over x. This is actually an example of the squeeze theorem. We've actually already done this one before in Unit 7, but it's good to review. Now, let's just evaluate this graphically right now, okay? Now, let me get a pen. Actually, if I were to use direct substitution right away, notice that I get sine of 0 over 0. Then I get 0 over 0, which is indeterminate form, and we're like, oh, shoot, like that can't be right. So we have to do some more work. Now, we can look at the graph first. Notice that we have this curve, okay? As we approach 0, notice what's happening to the left and to the right of this graph. And then you're like, oh yeah, that's quite simple. This equals 1, okay? And that's true. Sine of x over x is 1. Sorry, the limit as x approaches 0 of sine of x over x is 1, okay? You know, we know this because we can use this to evaluate other limits as well. And that's why this is something, although we never want you to memorize things in class, this is something that you will definitely want to know, use, and definitely apply in other situations, okay? And you're going to see what I'm talking about shortly, okay? So let's try our first example. All right, we're going to prove that the limit as x approaches 0 of 1 over cosine of x over x equals 0. And note that since we're proving, we only affect or change one side of the equation. Also, just as a note, because if you think this looks familiar, it should. This was a problem from one of our old reviews, but we're going to go through this together right now. Okay, so let me just rewrite this limit. The limit as x approaches 0. 1 minus cosine of x all over x. Now, since we just talked about this special trig limit, the limit of x approaches 0, sine of x over x, we just talked about how that equals 1. So somehow we want to change this guy and use that known fact. So let's start by multiplying by the conjugate of the numerator. Excellent. So now we have the limit as x approaches 0 of 1 minus cosine squared of x all over x. And I'm going to leave this as 1 plus cosine of x. Okay, I'm not going to change that. Now, if you're thinking in the numerator, you're like, ooh, I know. You're right. That is one of our trig identities. It's actually our Pythagorean identity. We can replace this with sine squared of x. Okay, leaving the denominator as is. So far, so good? Wonderful. Now, remember, want to use this special trig limit. So that way, at the end, we can replace something with 1. So what I'm going to do next, I hope you guys follow along with this, is I'm going to split up this sine squared of x. Oops, come on. I'm going to split up that sine squared of x. I'm going to have the limit as x approaches 0 of sine of x, and I'm going to put it over x times, here's the second sine of x, and I still have this in the denominator as well. Note that I didn't change the problem, right? This is a completely valid step, right? This is still a product in the denominator. This is still a product in the numerator. And as we have done before, we know that if I have a limit of a product, that's the same thing as the product of its limits. So I guess if I wanted to add in another step, just to be thorough here, because it's our first one. That's a multiplication sign, just so you know. Okay, so now we just talked about what this is. That's a known fact, okay? We're going to use this to evaluate this new identity. We know that that's going to be 1. And then if I use direct substitution for the second one, notice that I get, well, sine of 0 is 0 over 1 plus 1, but this will just equal 0. Ta-da! Okay, so in the examples that we're going to do next, it's going to be the same idea. We want to use what we know, the special trig limit here, to help us evaluate other trig limits. Okay, so let's try this one. We have the limit as x approaches 0 of tangent of x over sine of x. Okay, this one we actually probably won't even need to use our special trig limit. So let's see if you guys can figure this one out on your own. So go ahead and put me on pause. So I got an answer of 1. Let's take a look at how I got that. Now, don't forget, we're always looking to use direct substitution first. That's always our first look. But we got indeterminate form because we end up getting 0 over 0. So I expanded tangent of x to be sine of x over cosine of x. Then notice that my sine of x is cancel, so I'm left with 1 over cosine of x. Notice that I'm using good limit notation here. I show that I use direct substitution in this step, and I have 1 over cosine of 0, which is just 1. Cool. All right, I'm going to have you guys try these next 2 on your own, so do both before you unpause me, or at least get them started. My hint for this first one, you will definitely use that special trig limit. Remember that limit as x approaches 0 sine of x over x. So somehow you want to rewrite this guy. Maybe you can see it now. In this one here, this one's going to be a little bit harder. And you're actually going to use that special trig limit twice. Okay? So go ahead, put me on pause, try both, and then we'll check our answers. To check. So I think this first one was rather simple. We know the tangent of x is sine of x over cosine of x. If I group the sine of x over x and the 1 over cosine of x, well, I know that this limit as x approaches 0 is just 1. This I can use direct substitution, and I get that this total limit is 1. All right, now this one is a little bit more complicated. The first thing that we need to do is we need to multiply by 2 times sine of 2x over 2 times sine of 2x. If you're wondering where that comes from, one thing that I just want to mention, I'm going to write this on a new page, is remember that I had the limit as x approaches 0 of sine of x over x equals 1. Well, it's also true to say that the limit as x approaches 0 of the sine of, I'm just going to use a variable here, a over a, whether a is like 3x squared plus 4 or whatever it happens to be, as long as these match, it still equals 1. I mean, it's the same concept here, x over x, right? So in this case, we have sine of 2x. So I want to get sine of 2x in this denominator here, right? Sine of 2x over sine of 2x. But when I do that, I also have to multiply to the numerator, and I also need a 2 in front of this x, so that way I can use the same rule there. So now this might take a minute for your eyes to really see how I rearrange these. But I had the sine of 2x over the sine of 2x, which is what I multiplied here. So this is 1. The sine of 2x here, notice that the 2's in front, so I'm good there. And then I had times 2x. So these are grouped. Now notice that since these match, Maybe I'll highlight it for you guys. Since this and this match, and since this and this match, we're good to go. Now we can use that special trig limit. And now I know that I have, using direct substitution, I have 2 times 1 times 1, right? So that came from here, it came from here, and obviously the 2 came from the 2. So this limit equals 2. Oops. All right, last one. Let's have you guys try this one. Go ahead and put me on pause. Right, this one was not difficult by any means. This one was just a direct substitution one. So I substituted in my pi over 2 anywhere where I had an x, and I got 1 over pi over 2, but since I have 1 divided by this rational here, or this fraction, I can make this equal its reciprocal, which is 2 over pi. All right, so make sure that we know this guy here. The limit as x approaches 0 of sine of x over x is 1. We also have a special trig limit. I didn't really emphasize this as much just because we can find it using this. But we also know that the limit as x approaches 0 of 1 minus cosine of x all over x is also equal to 0. Both of these will come in handy as you guys are, practicing some more problems. Make sure you know your trig identities. Those are really going to come in handy here. You're not going to be given them on your tests. And then when we evaluate trig limits analytically, we're always going to use direct substitution first. That's our first look. Then we look to use trig identities. Then we might use special trig limits. And if it fails, then we would have to look at the graph or try numerically. If you don't know what that means, ask me.